think I've got the stability cracked on this. We were having issues with crashes. As of yesterday afternoon, I wasn't seeing any more crashes, although we are seeing some suboptimal performance and some weird behavior in the LOD function, which we're going to look at today. Um, so, like, so we'll go ahead and run it. This is a part of the effort of getting like neighbor finding and LOD stitching and stuff all working. We did that, and then it was unstable, and then we fixed the stability, and now it's got some performance issues, and it seems like a bug in the LOD level deeper than like 8, where it's like the LOD level is um, extending too far out to the edge. Like, this is wrong. Like, look at the difference in LOD here. And so we end up generating like way too much of the lowest LOD. Like you get, like it's even going out to the edge in places of the parent LOD. So that's probably first on the list because that's a huge performance problem, which we should be able to see here. Wait. Because we have too much, and it gets even worse if we go deeper. Like we're at 9 here. If I go to 10, yeah, look at that. And then we also have a little sequencing bug on the merge where it's having occasionally it's been able to merge a node or to destroy the child nodes before the node is visible. It'll go to 12 here and really cause it to blow up. And I do have a couple ideas, but you'll notice we're doing a ton of shit, but we're not crashing. Even though we definitely would have been crashing before, we're just lagging out, which is kind of fine. It's better than crashing. But yeah, it really chugs at higher depths. Okay, that's gonna lag. We're just gonna stop. All right, so let's make some notes before we get started. Why is our LOD function causing splits too early? Um, Optimization, clean up. So I do have one idea. It may have something to do with it. And I think what we need to do is change a little bit the way we're calculating some of these values. So we've got this update mesh data. So instead of I think we want to update. I'm just thinking. So we could get our triangle here, get our Okay, yeah, let's do it like that. So instead of updating the centroid information in generate vertex, no, we need it here. So we move our updates for our like global values into here, where we do like a check to make sure it's not on the edge. So we only want the centroid and the minimax radiuses to be calculated for the triangles that we're actually going to render. And we render an extra ring of triangles like virtually so that we can calculate smooth normals. All right. See if this has any impacts on. Maybe that was it. Okay, hang on. Actor depth. Hang on. Okay, okay. Yeah. So, yeah, that would cause a problem. So we need to add one more variable. Vertex visible. And then in here we can visible vertex count plus plus. And then down here something like this. Get some music going too. Okay. We still have the same problem though. Um, hmm. Interesting. Okay, so why is it doing that? So 0 through 1 minus face resolution. I think that's right. So if you were doing 4, this would be -1. Let's say, okay, so our face resolution in this case is 2. So that makes this 0, or I guess it would be 3 in this case. 3 vertices on the edge, right? So we're at 3. So if our face resolution is 3, our actual indices would be greater than -1 and less than our face resolution for 2. That checks out. Our actual visible patch would look like this, and we would have an edge here and here, here and here, here and here. Okay. So I do think our calculation's correct here. Ignore virtual tries for the purpose of calculation. Okay. Okay, this is wrong. This should be... Okay, this is probably the problem. This is probably the issue right here. Oh, wait, no, no, stop, stop. Oh, fuck. Stop. Alright, so I think we need to use the centroid. Unless we're going to use the center on the sphere in our LOD calculation, we need to use the centroid in our node radius calculation. So that means we get rid of this. Come down here. Max node radius equals... Wait, did I copy it? Damn it. Copy it. Okay, yeah, this is gonna work, I think. So, we generate the vertices. And then down here, we had one check here. Was all but this. Alright, we got to figure out this lot issue first. We fix this, then we move on to optimization strategies. We got, I mean, the stability fix is big from yesterday. Being able to do this without crashing intermittently is really nice. Okay, yeah, that was it. That was it. We can't use the center on the sphere. We have to use the node centroid. And it looks like that is working. So let's go ahead and try to pump the depth up a smidge. Let's do 12. All right. Okay, all is right with the world again. And like I said, that was a huge part of our performance problem right there by itself. Because if we're having our smaller LODs overflow their intended boundaries, then our performance is going to be fucked. It's actually running pretty well now with a 12 depth. Stitching is still working properly. Yeah, so that was actually the primary cause of the performance problem too, it would seem. Hmm. Let me get to this mountain range over here and see what it looks like with the full resolution. So far seems pretty rock solid on stability. I mean, that looks pretty good. Oh, we're on the dark side of the planet though, so obviously we still have to go in and make our planet materials and such. Our atmosphere is pretty much feature complete. We're getting close to having our mesh generation be feature complete. Then we're gonna need to look into like materials and different noise formulas again. Although we have a series of noise formulas for different style planets. Um, and it looks like our LOD issue was because of using the center on the sphere rather than the displaced node centroid. Um, I did that to try and make it so that I could do all the calculations in one pass, but we just can't do it that way. Because like so the node centroid is calculated as the average of all the visible points, all the visible verts in the node. So if I got like a mesh, and it looks like this, for instance, every time I insert a vertex, so here, 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 here. So every time we inject a new vertex, a visible vertex, because remember we have an extra ring of like ghost quads that we use for smooth normal calculation, but these aren't rendered. Only the center patch is. So for each of the center patch vertices that's going to be visible, we need to sum them. And then we need to divide the sum by the number of visible vertices. And with that, we get the averaged out center of the displaced um, mesh. And I was trying to use the center on the sphere as the center, which would be the like pre displacement place on the sphere, which obviously was causing issues. So let's go ahead and set up a commit for that. Fix LOD issue. Stability seems good still. Let All right, so next up we need to do, so we basically are feature complete here, but we need to do like a cleanup pass uh and make sure that everything is as clean and as minimal as possible. And then we need to start playing around with multi-threading and trying to get as much of the heavy lifting off the game thread as possible, which we're already kind of doing. We're doing like a kind of a double buffering approach. So woo. Oops. Oh, and we have a sequencing issue. We could just see it there for a brief moment. It's not like the end of the world, but it's definitely something we can fix. So let's get all the way down so that full detail has been loaded in, and then if we zoom out, okay, never mind, it didn't trigger. Come on, come on. All right, damn it. Of course, now it won't work. I saw it happen though. There was invisible sections in the mesh. but now it won't fucking do it. But I saw it, so I know it's a potential issue. We're gonna make a note. Um, merge sequencing midly um, clears children before parent is fully visible. Okay, fix this. All right, we need to do like a little self code review here. There is lag here if you're moving quickly. All right. Okay. So we're gonna close this down. We're done with that for the moment. I'm gonna get some music, some nice royalty-free robot-generated music. Let's try this. Let's go ahead and close tabs to the right. All right. So I think there's nothing to it but to just go function by function, line by line. Center on sphere. Am I using this anymore? No. Although I could see it becoming useful because we still have some sea level stuff we want to do. And if we change the way sea level works, right now sea level is just at the radius. If we change the way sea level works, then having this will be useful. Alright. We'll leave it for now. I would love to get the state a little bit less complicated. It is freaking out, actually. Let's regenerate our project files. We have it working pretty well. Yeah, and then while it's doing that, this. Okay. And, ooh. Oh, no, and it's goddamn YouTube autoplay. All right. Damn it. Fuck. All right. All right, do this. Grab the remote. Turn this off. So usually watch that with Lindsay, and then back over here. Excuse me, there's no way it's not. I mean, it's having a problem linking the code together. Alright. Okay, so let's start at the top of here. Okay, so we have our constructor. It takes an apparent actor, a noise generator, an index, min and max depth, a face transform, a center point, a size and a radius. We set up the face resolution, we set up the neighbor LOD to be our own depth. Seems okay. Alright, next up, update LOD. Obtain a lock so that we can't enter this function again from the same node. We're invoking it from the root, so that should be okay. We remove the recursion. I'm not sure this matters. Alright, so okay, so we are code reviewing now. I got stability working pretty well. We are cleaning code, optimizing. I am going function by function, quad free node. First off, we
I don't think that doing a second loop to reverse process order is necessary. We can just do evaluation in the main loop. Operation main loop. Parent nodes do something. Anyway, better to have less iterations since plus times per second. Nah, nah.
don't know if you can do it like this. We're gonna try. Wonder why it felt the need to do it that way. Doesn't really make sense. Something went wrong though. What? Okay, so yeah, so we should be able to just invoke this. Uh, wasn't sure if that was gonna work or not, but Yeah, like this check is probably just costing us a lot of performance right here. Actually, I don't think we need to check this. Shouldn't actually need that. Okay, we're lagging. Shouldn't need either of these in that case. My god. They got it working, but it's not pretty. Right, at least it loaded to this point. No, it's not working. Alright, here's what we're gonna do. Undo everything. Copy this. Let's get a second opinion.
Where's my settings? Alright, now. It's the three, four, two,
second opinion. This is closer to what I thought it would be. Okay, why are we going backwards? Alright, we're back. And that's going to be a pretty big optimization. Okay, and there was the thing I was talking about with the ordering. Like something slightly off in our ordering of merges. Oh, it's like a lot faster actually. Because like every time we do that contains check, we have to iterate the whole loop. So we're effectively making it a two-dimensional loop when we do that. Doesn't need to be this complicated. I don't think it needs to be anyway. But this is already like way better. Like we don't need this heavyweight dual processing loop that it came up with. Probably just because it didn't want to change the order that operations were happening in. We don't really actually care. It's just that simple. And paste. Alright. I think that's pretty well optimized. Alright, so next up we've got So we update LOD. That looks good. Update neighbors. Can copy the same thing. Alright, so leave. Something like this. Something like this. Get rid of this. Get rid of this. And we may actually only need to run tri-set lot on the leaf level. Well, you know what? It's really fine because, like, if we take a look at this, if initialized and is leave. Okay, so we're already checking it. It's just the if is in that spot. I think that's fine. And then likewise, this looks good. Alright, so we flattened both of those, turn them into iterative functions, so we shouldn't get stack overflows anymore from recursion. And we're trying to make their process of gathering the children as fast as possible as well. And go away. Alright. Neighbors are still matching. There's still a little bit of chunkiness, but it's definitely faster than it was a few minutes ago, so this is a good change, I think. Oh, what happened? It's the first crash I've seen in like a couple of hours. Interesting. Very interesting. I mean, if it keeps popping up. Alright, well maybe not so fast about committing that. There we go. Damn. Alright, well hold on. Curious about some. Well, interesting. So let me. Change to iterative. Alright, so we go right back. See if we can trigger that bug. Jeez, Jinx. Holy crap. Having a season fit? I have another idea. Alright, we're gonna try a different version. Can I actually just do it like this? That should be pretty quick too, and this actually has some benefits in that we may be able to parallel for here. Maybe. Lift all the leaves. Set lot on all the leaves. And then we just have to optimize this one function. See what happens. I mean, it's working. I mean, that's the fucking way right there. Simple. This is dead simple, easy to understand. If you need to figure out the leaf node collection, and it just always operates on the leaves. Alright, so here's the fun part. Can we... Probably can't parallel 4 here, but we might be able to here. Template for the parallel 4. Wait, I pressed backspace again. Alright, let's try the neighbor update in a parallel for. I fear that if I do the other one, because it's modifying the tree structure, that it's going to blow up, but we can try it. It doesn't hurt to give it a shot, right? I mean, if we could do this in parallel, it would be big. I have my doubts. We're about to find out, though. Seems kind of like it's just working. See, and like just with that, we get a huge gain, and it doesn't feel like chunky anymore. Alright, so I'm pretty cool with that. And that's a pretty big advantage of collecting them as leaves first. God, it makes it such a great looking little method. It's wonderful. I'm not sure this matters anymore. I don't think it is. We're not using it in neighbors. I mean, we're gonna find out. Test it out and see. Spin my credits. Okay. So far, so good. We'll leave that little bit commented out for now. That's pretty great. Right, and then the next one that we're gonna do should become immediately obvious too. Get as many of this stuff into as many threads as possible. A little bit of lag when I'm going fast, but if I had it at a manageable speed, I don't think you would notice it. That was a problem. That probably just has to do with our sequencing issue that we currently have with the merge function. It seems like when we're pulling back, we get that sometimes, where like it's removing the children before fully rendering the it might be something as simple as just putting the child destroy, like redispatching it to the game thread so that it happens on the next frame. But yeah, that's an issue. Okay. So far so good with this kind of parallel iteration. Let's take a look at merge. Only the last one tries. Yeah, so let's do this. Gonna do it or fail? Fail. Why are we doing it like this? We already hold a permanent reference to this. Now let's just do this. And then we can add in what do you mean? Alright, fine. You know what? Forget I asked. Try and fix it from clearing nodes before they have fully generated their mesh. And hopefully that'll be enough to stop the random holes from appearing and things failing to merge. At least didn't break it. That's a good sign. Ready, set, go. Oh, there's one little split second. That one did pretty good though. I think it's better. So there's still a potential small delay between generating and rendering. Okay, another idea. Okay, yeah. if it enters into this block even a single time, it's going to have rendered by the end of it. And then in our merge function, okay, that makes sense. We don't want to delete a parent until after his children have generated. Nope, that's worse. It wasn't too bad. Yeah, that's way worse. Okay. Stop. I was pretty happy with this one. Yeah, like there's still like one straggler, it would appear. Oh, you know what? I do have an idea though. It already does that. Do our check on the thread that we dispatched to. Yeah. No. Fuck. Hey, yeah, like we're already checking it here actually. What's up, dude? Alright. God damn it. It's just as bad, if not worse. Worked that time, though. At least stability seems good so far. I shouldn't have said anything. To be fair, you wouldn't be encountering this in the actual game. But I like to boundary test this shit. Unfortunately, this is in the third party stuff. Alright. Nope. Good with this. Hmm. Okay, so first of all, we have some redundant shit here. Is valid, is leave, is restructuring, is valid, is leave. We don't need this. We're just gonna downsize the ones that we think are working correctly. Check neighbors is gonna need its own pass probably. Just a chance to look straight at that. And that only. Hello. Alright, back for a little bit. I might not even need the recursive call. I think I was doing it like this for a while. If I don't have to make the recursive call, I shouldn't do so. Let's just try resetting it and letting their natural destructors take care of it. Yay, jeans. Seems to not be oh, no, maybe not. Alright, we got a deadlock, so does require the recursive cleanup. I don't actually need this. To remove children is going to do that anyway. Fair enough. Could there be a continue here? I think there's supposed to be a continue right there. Hmm. I'm sleepy this week. Oh man. Alright, hold on. I revert both of those. And probably just comment this part out because I really don't think that we should have to do that. But go back to the old children processing just for the moment and see if it still is locking up. Oh, good. Mm. Okay. So this much at least works, and it's not breaking or anything like that. explicitly reset the child arrays of all the nodes that are getting deleted after we invoke destroy chunk. Oh, excuse me. Sorry. I'm not expecting this to fix the zoom out thing. I just want to find the most efficient. Well, maybe it does. Just want to find the most efficient cleanup method. It actually seems to be working better. Still has a couple hiccups. Oh. It's interesting. It happened on the game thread too, which is kind of crazy. Should only be a read. I think. We're not changing. It also might be worth moving the read lock into the individual if statements. Trying to break it again. It seems pretty good. Like, I think you would have to be trying to hit this bug. Because, like, we're definitely not going to let the player move that fast. Alright, so... probably not much difference. For every panel, we should have to render an edge. So... So we just do the last render check inside the edge check, which should be the last thing that happens. And then, now that might fix the problem. Nope. Damn. I'm really at a loss for what's causing that. It shouldn't be able to fully merge until after the last rendered state is true. You know what? This is supposed to be... Okay, yeah, there's this. Yep. How about that? That's gonna fix it. What do you mean? Is this insurance surveillance to be done what the fuck you talking about? Alright, so trying to find the right place to set this and to keep it from being prematurely set. Because right there is being set in the initialized chunk, and that would make it null. There it is. That's it. That was it. So yeah, we were setting it in the as true in the chunk initialization, but that's just generating an empty real-time mesh chunk. It's not actually populating the data. Yep, that's it. Hell yeah, that's another bug squashed. So yeah, that was what was going on. Since we were calling set last rendered state in initialized chunk instead of update mesh, it's like it's going in with no data in it, and then it's saying that it's been rendered, and that's how we could get blanks while you're zooming out. But now our last rendered state is managed more correctly. That should actually fix some of the stability all over, because that would have stability implications with things being flagged as rendered before they've actually been rendered. It's gonna be fun when we get into like the foliage and stuff, like proc generation of using the PCG system, because I know you can use that with real-time mesh. I've seen people do it. God damn it. What the hell? Alas. Hey, buddy. Excuse me? What? The fuck? There's an issue with our Ray Marcher here that I'm gonna want to figure out eventually. It's like we need a better boundary checking on this atmosphere shader. Like, we should still get this view of it, but it shouldn't be affecting the stuff outside of its zone, and right now it is. And I think that's part of that, kind of. I don't know if anybody can see that. But there's like a little line, and it's coming from this remark shader. We may be able to, we can probably figure out how to stop these cracks while it's waiting to calculate the edges too. Let me try something. I'm gonna see if we can invoke check neighbors here. Seems to be working. It definitely goes a long way. Like, I can still see it occasionally happen. And then in merge, we could check neighbors too. Nice. It pretty much gets rid of it. Hell yeah. Alright.
UE, exceptional by design. Get 0.9% APR on these UE5s, but for another will not be on level with thousand onward.
Nice. Yeah, I'm not seeing the same cracks pop up during transition. That's really nice. It's feeling quite a bit better too. right? Good stuff. So we can probably I'm gonna get rid of this. We definitely don't want to be doing like we don't want to be doing checks against the entire node array in this loop because that is very expensive. Doing like contains on every loop iteration. We also don't need this complicated indexing that they've done here. I equals 0, I is less than 4, I plus plus. That's actually a pretty big performance gain just getting rid of that contains there. Because this happens a lot during merge. Potentially a lot. Oh, but we got a deadlock with that. Why is that? I'm not sure why that was erroring out. Or not even erroring out, it's deadlocking. Nope, deadlocked again. Okay, why would that cause a deadlock? That was the only changes, right? I really don't think it's this contains. But I guess this will tell us. It's gotta be... I don't know why why it would. Doesn't really make a ton of sense. Shit. Select again. I feel like I shouldn't need the second loop. It's funny, this shit is using the processor somehow. Alright, so we need to be deleting the 4 minutes because they're bad. Alright, you know what? It's gonna be fine for now. Okay, should split is fine. Split everything. Make new children. For each child, check its neighbors. Then render it. Is leaf is fine. Get depth is fine. Collect leaves. We use this in a few places. Alright, we don't need all these comments. That's fine. This is fine. That looks fine. This is fine. I don't think we actually need this check anymore. That's vestigial. We were doing, I like hacked together to make it able to like use it as an ocean by making it handle the noise generator being null, and we needed to render to the depth buffer because we use that in our atmosphere calculation. Okay, that makes sense. Should this be a game thread? We have it wrapped, but I do want to use this instead of the other one. so that we're using the same async calls. Alright, assuming that works, I'm good with that. Interesting. So this should probably be on the game thread. By probably, I mean definitely. We're not supposed to be messing with the parent actor or the chunk component off of the game thread. This might be our intermittent crash, actually. I don't know what's going to happen to performance, but it should be pretty light to remove and destroy a component. Should be pretty lightweight. No, that wasn't it. Don't do this, man. Destroy chunk. Line 407. Okay. It's line 407. Gotta check it when I get back in after this crash. Alright, so what we're gonna do is instead of this and this, we're gonna go the invoking spot. Try wrapping this whole process. So we don't just have hundreds of, like, each individual merge isn't causing multiple dispatches of the game thread. So far, so good. Come on, work. It feels better. Alright, you know what? Knock on wood. I think we may have fixed it. Let's commit these changes. False. Initialize that. Hang on, what were these changes again? Node destruction. It's good. So far, so good. I think we might be there. I mean, like, I could always use more cleanup passes. There's just so much code here that's, like, pretty intricate. I mean, it's a 1,000-line class, which is not insane when you have a lot of boilerplate. But this is like 1,000 lines of, like, math operations and tree processing operations, which is pretty fucking dense. Like, if you're sending, say you're sending a bunch of HTTP requests or something, and every request you send is like 50 lines and you're writing a service class and it does 100 different things, and yeah, maybe not 100, that would be ridiculous, but like a lot of things, and then it has some additional processing, it's pretty easy to hit 1,000 lines in a class like that. But in just a basically data structure management class, 1,000 lines is heavy. Alright, so what I like to do... I don't need it. If I'm not using that, I don't need this. So, like, what I like to do is basically, once I think something's done, I always go back through and check every class line by line again, and then I'll shrink them. So that's good, that's good, that's good, that's good. Check neighbors. Okay, so let's add a to-do here. This doesn't improve our performance or stability, but improves our code readability, so I don't want to worry about it right now. But like to do edge processing neighbor can be broken out into its own function, complexity, fit. But we'll leave it for now. Can I do this? No. In fact. Function used in triset. There's only one place we're calling this. One place we're using that. I really don't like just having that no context. I would rather have like the whole function be procedural than have some no context function sitting there that just says S and does some arcane math shit. Just have it be a part of the inline check. Oh wait, though, hang on, should split might be using it. That's why we did it. Okay, never mind. Never mind. Alright, so like, because we're using it in two places, I'm gonna leave it. May not need this anymore. We added this to try and stop the merging, but we fixed that. Looks like my mic wasn't working, maybe. Either way, doesn't matter, it's just coding. We're really close here. Really, really close. Still working. kind of want to do a should merge, even though okay, parent size D2 FOV. Doing a redundant. We're doing a redundant D1 check here. Instead of putting in the centroid in the cam position, we should just be directly feeding in D1 because we've already calculated it. So should split should change to double, double, double. One. And we can get rid of this. And Teddy, chill the hell out. You dingus. You silly pup. And should merge is parent size D2 FOB and K. So D2 double parent size double FOB double K. Never mind. Skip, skip, skip. Let me just get rid of this. And then over here, it's literally just return this. And this gets D2 parent size 5K. Oh, yeah, that looks much better. And then that also has the added benefit of allowing us to move this annoying little S1 function Down here to live with should split and should merge. Okay. Okay. Let's make sure we didn't blow it up. Seems fine. Yeah, seems absolutely fine. Okay, great. Vote on the parents with child states checks all children first. Allowing a merge if all beautiful. Now split. I'm actually gonna move. I want split before merge. Just trying to order these in a logical way, right? Like splits happen before merges usually. Merge is gonna happen before. I know it doesn't matter. It matters to me. Oops. Nope. Don't copy blank lines. Join game thread to perform component destructions. Okay, that's good. This is fine. This is fine. This is fine. It's fine. That can come later. Okay, these I think have not changed in a long time. These are kind of locked down. This is fine. The edge mesh buffer. Yep, that works. That works. This works, although might be worth a once over. It looks good. Finally, we got update mesh. Seems fine. This looks good too. All right, I think we're done. I mean, we have a couple things. Let's make note of the remaining to-do items here. All right, so there's, initialize stream builder currently is likely allocating too many vertices. Tries for the edge buffers. We can calculate it better. Check neighbor edge function can be edge check can be broken into its own function. This is complexity. You about ready for dinner? Alright. Dinner time. All right, I think this looks good, at least for the tree. This should hopefully be the last of the changes I have to make. I'm gonna get some dinner after I commit this. I could add documentation. That's like next. Get all this documented up, but like this is pretty good. I think the order that I've grouped all these functions makes sense. So update LOD, update neighbors, update all meshes. These are things that are called externally that like do a child crawl basically. Check neighbors is used in update LOD. Try set LOD is used in update LOD. I think we should do it like this though. Because it's like they're more proximal. So like update LOD calls try set LOD, update neighbors calls check neighbors, update all mesh calls update mesh. But this is down here with the mesh updates. I think maybe if we're following the paradigm we've set out here, it should be here. Structuring operations. Channel, already child collection. Mesh stuff. finish data generation can be multi-threaded. Okay. Yeah. Awesome. Let's make sure that we didn't break anything. I don't think we did, though. Jesus Christ, Jinx. Chill the hell out. Oh my god. It is not that bad, dude. Jinx. Alright, awesome. Everything still works. Pushing it up. One tree. Green node cleanup. Pass. Function reorder. Okay. I'm getting some dinner. Later.